Have you ever wondered where the ingredients for stars, planets, and maybe even life itself came from? Deep inside a giant cloud of gas and dust, scientists have found something that could change how we understand chemistry across the universe. Today, we're exploring the Taurus Molecular Cloud 1, or TMC-1, a dark, cold region more than 400 light-years away, where astronomers are finding surprisingly complex organic molecules forming long before stars are even born. The Taurus Molecular Cloud 1 is one of the most studied regions of the night sky. It's cold, about 10 kelvins or 263 Nacht. Yet it's packed with chemical activity. In these frigid conditions, gas and dust clump together, eventually giving rise to new stars and planets. But what really surprises scientists is that large, complex molecules can exist here at all. Until recently, most researchers thought that kind of chemistry could only happen in warm environments. TMC-1 has proven them wrong. In 2024, a team from MIT and the Center for Astrophysics, Fuku's, Harvard, and Smithsonian made a stunning discovery. Using the Green Bank telescope in West Virginia, they detected a molecule called 1-cyanopyrene, a modified form of pyrene, part of a family of compounds known as PHs, or polycyclic aromatic hydrocarbons. These molecules are made of fused carbon and hydrogen rings, structures similar to those found in coal, oil, and even in meteorites that land on Earth. The shocking part? Scientists didn't think such large molecules could survive in cold, dark space, but they breathe there, and they make up a measurable fraction of all the carbon in that cloud. That means complex organic chemistry can start long before stars ignite, rewriting what we thought we knew about the origins of life as building blocks. And that discovery was just the beginning. A new survey, totaling more than 1,400 hours of telescope time, has revealed over 100 different molecules inside TMC-1, including at least 10 aromatic compounds. Many of them contain nitrogen, oxygen, and carbon, key ingredients for biology. Even more surprising, some of these molecules are highly unsaturated, meaning they have multiple double bonds, which normally require energy to form. Yet somehow they're appearing naturally in a place colder than Pluto. Simulations published in Chemistry World suggest that these molecules might form on ice-coated dust grains, where radiation from nearby stars sparks tiny reactions. It's chemistry happening in the dark, quietly, hundreds of light-years away. So what does all this mean? It means the universe is literally a factory for organic chemistry. Before a star is even born, the raw materials for life are already taking shape. When new solar systems form, these molecules can become trapped inside comets and asteroids, and eventually delivered to planets like Earth. Samples from Japan's Hayabusa 2 and NASA's OSIRIS-REx missions confirmed that meteorites carry complex organics strikingly similar to those in TMC-1. In other words, the same chemistry happening in that cold Taurus cloud may have seeded the very molecules that made life possible here. Detecting such big molecules isn't easy. Some have no electric dipole, making them nearly invisible to radio telescopes. The next step is to search for even larger PAHs, and to check whether this chemistry continues inside protoplanetary disks, where planets are forming right now. With the James Webb Space Telescope, the Vera Rubin Observatory, and future radio arrays, astronomers are preparing to map the chemical universe in unprecedented detail. In the end, these discoveries suggest that life, or at least its ingredients, might not be rare at all. It could be the natural outcome of the universe's own chemistry, and the idea that everything began in a cold, silent cloud in the constellation Taurus is just mind-blowing. If you enjoyed this deep dive into the hidden chemistry of space, hit that like button, subscribe for more cosmic science, and tell me in the comments, what molecule do you think the universe is creating right now? Until next time, keep looking up, because the sky is way more chemical than it looks.